Okay, today we're going to talk about the basics of triangles and how to tell what type of triangle we have using its angle measures and side measures. So we're going to be able to identify and classify triangles by their angle measures and their side measures. Okay, so we have our basic triangles for angles here. An acute triangle has 3 acute angles. An equiangular triangle has 3 congruent acute angles. So congruent means equal, all those are the same. And the obtuse triangle has 1 obtuse angle. And of course a right triangle has 1 right angle. And they note here an equiangular triangle is a special type of acute triangle. So it is still acute, all 3 sides are acute, but they are all exactly the same. By sides, we can identify equilateral triangles, which have 3 congruent sides, isosceles triangles, which have at least 2 congruent sides, and a scalene, which has no congruent sides. So again, that equilateral triangle is a special type of isosceles triangle. So it has at least 2 sides that are congruent, but equilateral, all 3 of them are. So, classify each triangle as acute, equiangular, obtuse, or right. Looking at this one right off the bat, I can see that all 3 of these angles are exactly the same. Therefore, it is equiangular. Looking at our next one, we're noticing that this one here, 130, is greater than 90 degrees, and greater than 90 degrees gives us obtuse. You can only have 1 obtuse angle in a triangle, so that is it. That makes it obtuse. Next, classify triangle XYZ, that's this whole triangle, as equiangular, obtuse, or right, and explain your reasoning. So we're looking at the triangle as a whole, and noting that they gave me 2 measurements for this corner, my other 2 angles being 50 and 40, and this one being 40 plus 50 combined, which gives me 90, which we know to be a right angle. All right, the triangular truss below is modeled for steel construction. Classify JMN, JKO, and OLN as acute, equiangular, obtuse, or right. So we have several different triangles here. So we are going to start with JMN, which is the whole angle here. I'm seeing that I have at least 1 angle that is above 90 degrees. That makes this one obtuse. My next one, JKO, is this little one here. We can't be positive without a protractor, but it's looking to me like I have a 90-degree angle right here. So we're going to classify that one as right. And the last one they want you to look at is OLN. And again, you can't be positive without a protractor, but kind of looking at it and based on the information we have, this one would be equiangular. At the very least, it has to be acute, but it looks to me like they may be all the same angle as well. Okay, so how can we use this information to classify equilateral, isosceles, or scalene. So looking at measurements now of the sides, if point Y is the midpoint of Vx and YW equals 3.0 units, classify triangle VWY as equilateral, isosceles, or scalene. So that's this one right here. And the reason they're mentioning that midpoint to you is so that you understand how much this amount is. Since it's a midpoint, Vy is only going to be half of the total, so that's 4.2. And then they tell you here that Wy is 3.0. I'm seeing all three sides are different measurements. That makes this scalene. All right, we can use algebra to find measures of sides if we know that they're isosceles or equilateral. So in this case, we have an isosceles triangle, KLM with base KL. They reference that the base is KL because that tells me that the sides, LM and KM, are going to be equal to each other. So I'm going to set the measurements for each of those angles equal to each other. LM is 12 minus D, and KM is 4D plus 13. And then we're going to solve our equation. So I'm going to add D. 12 equals 5D plus 13. Oh, it should be minus 13. Oops. Okay, minus 13. That makes a lot more sense. And then we're going to add 13 to both sides. 25 equals 5D, and divide by 5. So we now know that D equals 5. And then we can plug that back into each one of these, and they asked you to find all three sides. So we're going to go back and do that. So LM is going to be 12 minus 5. So LM equals 7. And then KM is going to be 4 times 5 minus 13. So we're just plugging 5 in for the D. Don't need that extra parenthesis. Okay, and I get 20 minus 13. So that one is 7. They are isosceles. These sides should be equal, so we could have just figured that they would both be 7, but I'm proving to you that that does work. And then the last side, KL, is just going to be 5 plus 6. So KL equals 11. And we have found all three sides of our isosceles triangle.